Hello everybody, this is Dr. Christopher White, and in this presentation we're going to continue thinking about sedimentary environments and sedimentary rocks. So now we're going to think about sedimentary environments associated with near shorelines, so coastlines, and the oceans, and this is going to correspond to section 7.2 of your textbook. So if we look at our diagram here, we can see a coastal environment. So here's the coast running along here like so, and you can see we have environments which are associated with the coast, and you can see we have environments which are associated with the water, the oceans. So we're going to have environments such as the beach environment, where sediment is being moved around by waves. We're going to have environments like reefs, so essentially these are going to be sediments which consist of organic material, so for instance coral and other assorted shelly material. We're going to have lagoons, so these are lower energy areas of water which are protected. So a lagoon can occur behind a reef because the reef offers protection to that area, or a lagoon can also occur behind barrier islands, which are linear bodies of essentially sand which build up parallel to the coast. They're also protecting an area of water behind them, which we would refer to as a lagoon, and typically a lagoon is a lower energy environment. We would have coastal dunes. This is where the type of sandy material which is being moved around by the waves at the beaches is instead being moved around by the wind, because this area is inaccessible to waves, so it's, the sediment cannot be moved by them, but there is a breeze going over this area. There is wind going over this area, and so that's going to move the sediment. And so we're going to see the same kind of features that we would get in a desert environment, aren't we? We also have areas such as tidal flats, and so this is an area which tends to get inundated during high tide and will become exposed during low tide. And these areas tend to consist of a mixture of muddy and sandy sediment. Of course, we have deltas as well. We've already discussed those. We are going to have offshore deltas, so this is essentially the environment in front of the delta, which is actually covered by water all the time. We're going to have barrier islands, as we mentioned, and then we're going to have a deep marine environment. So, a very low energy, very deep water setting. So you can see along the coastlines and in the oceans, there's lots and lots of different environments in which sediment can be deposited. But once again, just like the previous presentation, this is only a fraction of the total types of environment which can actually have sediment deposited in these areas. So we're just looking at the main ones right now. So let's start by thinking about beaches and coastal dunes. So we know straight away that the vast majority of beaches consist of sandy material. Now, this isn't always the case though. You can also get beaches that consist of quite pebbly material. Now, the question is well, why is that? Well, it can be for a couple of reasons. The first reason is the energy of the waves. So if your beach is being hit by big, strong waves, this will typically mean you'll have the capacity to move larger sediment around, and so your beach may well consist of larger pieces of rock, which we would refer to as cobble or gravel. The other thing is that the sediment that makes up your beach is going to be a reflection of the material that's being eroded. And typically the material being eroded to add sediment to your beach is a mixture of material that gets transported along the coastline and material that's being eroded from cliffs behind your beach. And so the material being eroded to actually form material for your beach coming off the cliff, for instance, in this picture, may well be affecting the beach sediment itself. And obviously if the material that's coming away from this cliff is quite solid and quite robust and doesn't break down easily, chances are it's going to form larger chunks of rock, and so once again we would get a beach which would contain cobble and gravel sized material. So the type of sediment that makes up our beach environment is variable. You can have sands, or you can have larger, more gravelly and cobbly stuff. In the sandy material, we're going to have these asymmetrical waves that we spoke about earlier, being produced by a wave coming up the beach. Asymmetrical ripple, being produced by a wave coming up the beach and then travelling back down the beach. That's transporting sediment in two directions. And so this is going to produce a symmetrical ripple. So that's going to give us an idea that there were waves in this environment. Now, you're thinking, well, hold on a second. How can I tell the difference then between sediment that's deposited on a beach along the coast and sediment that's deposited along the edge of a lake? And that would be a very good question. Well, you would use other indicators, and one of the other indicators you would use would be fossils. So within this sandy sediment here, there are probably going to be pieces of fossils which would only occur in environments associated with salt water. In contrast, the fossils that we would get in our beaches associated with lakes would provide fossils which were formed, well, could only really live in freshwater environments. So you can see that although you have sediments that would superficially appear to be almost exactly the same, if you look at them in fine detail, you can find indicators that allow you to work out the exact environment in which that sediment was being deposited. Now, behind our beach, we're obviously going to have sandy sediment as well, but this sandy sediment is inaccessible to waves. So if we look at this picture here, we can see that this area in the front of the beach, this is the area that's going to be affected by the waves. So we're going to see symmetrical ripples in this area being produced by the waves coming up and then coming back down the beach. In contrast, back here, this sediment is going to be moved by the wind, and so we're going to see a build-up of sediment which is going to lead to the formation of sand dunes. So once again, you've probably just thought to yourself, hold on a second, how can I tell the difference then between this sandy sediment here and the type of sandy sediment that's deposited in a desert? And once again, we're going to look for those fossils. This sandy material here is going to contain fragments or fossils, or complete fossils of organisms which can only live in saltwater environments. And so that's going to allow us to work out that, right, this sediment is deposited in a beach environment, whereas the types of fossils we would get in a desert sand, for instance, would consist of things like reptile bones. And so you can see there's going to be differences, and that's what's going to allow us to distinguish between these different environments. Now here we have a reef environment. This is a picture of a coral reef. We know that these are extremely organically rich and diverse environments, and lots of the organisms that live in these environments will use calcium carbonate to build skeletons. So think of things like oysters, for instance. So the shell of the oyster is considered to be an exoskeleton. Think of your coral. The framework on which your coral lives essentially is made of calcium carbonate. So when the organism dies, the organic portion is obviously going to decompose, but the fraction that's made of calcium carbonate is going to persist. It's not going to break down. And so all of this calcium carbonate material is going to be incorporated into the sediment. And so we're going to end up with a sediment that's very, very rich in calcium carbonate. And this is going to lead to the formation of rocks such as limestones. Now, the thing about reefs is they tend to form in deeper water, typically right on the edge of a shallow body of water just off the coast, which we call the continental shelf. And the continental shelf is typically between about 0 and 200 meters deep. And reefs like to form along the outer edge of the continental shelf. So they tend to form in deeper water. However, they don't form everywhere because you need specific conditions. So for instance, you need clean water, you need warm water, that water needs to have a normal salinity. That water needs to be located relatively near the equator, hence the fact because it needs to be warm. And so you don't get reefs forming in every environment because these conditions are not always met. And so where we do have reefs forming and therefore leading to the formation of limestones, that gives us an indicator of the environment. So when we see a limestone in the rock record, we can say, right, chances are this limestone was being deposited in relatively shallow marine conditions. The water was quite warm, and this means we were probably somewhere near the equator at that time. So you can see there's lots of information contained within these sedimentary rocks. Now, in the case of a lagoon is simply a protected body of water. So it's a body that has some kind of barrier in front of it that helps to reduce the effect of other sedimentary processes. So in the case of this environment, we can see we have a reef situated in front of our lagoon, and this reef is going to help to break up waves. So it's going to reduce the energy to which the sediment in this area is exposed. We can also have lagoons behind the barrier islands here as well. That's going to do exactly the same thing. The barrier island is going to reduce the energy of the transporting medium in that environment. So lagoons are often quite low energy. And so we're not going to get coarse sediments. What we're going to get is we're going to get lots of finer stuff, so fine sands and lots of mud. And so you can see how, once again, the energy of the system is being directly reflected in the sediment. And then, of course, what we can do is we can also look at the fossils, and we can say, right, the fossils we can see in these sediments, they're from a saltwater environment, so we know this lagoon was coastal. Along the coast itself, we have a range of different environments, but arguably the two more common ones would be tidal flats and deltas. So deltas, we've already touched on them. So a delta is simply where a river enters a body of water, and that body of water can be an ocean, a sea, or a lake. And of course, when the water is moving in the river channel, it has velocity, it has energy, so it's moving. As soon as our water hits our larger body of water, our sea, our ocean, our lake, the water in the river decelerates very, very quickly. It comes to a near complete stop. And so this means as our river water decelerates, it has to start dumping the sediment it's transporting because it's losing energy, which means it can no longer move it. And so we see the build-up of sediment being deposited in the form of a delta. So deltas are very, very complex environments because obviously we're going to have an interplay between several different sedimentary processes. So a delta is going to have sedimentary processes associated with the rivers, which are transporting the sediment in. You're going to have sedimentary processes associated with waves along the edge of the delta. You're going to have sedimentary processes associated with tides, and you're going to have sedimentary processes associated with the wind blowing the sediment around that's exposed on the top of the delta. So you can see a delta is a very complex sedimentary structure. Now, in the case of tidal flats form where we have a relatively protected area of sediment that typically gets covered in water during high tides and gets exposed to the atmosphere during low tide. So we have an environment where 12 hours of the day it's underwater and 12 hours of the day it's exposed to the atmosphere. So you can tell straight away we're going to once again have a very interesting juxtaposition of different sedimentary processes. So we're going to have sedimentary processes associated with the movement of water for 12 hours of the day, and sedimentary processes associated with exposed sediment for the other 12 hours of the day. Now, in the case of tidal flats, that's going to lead to very, very distinctive sedimentary structures produced by the tides, tide coming in and tide going out. And it's going to produce a very, very distinctive type of structure which we call herringbone crossbedding, and it's one of these things that a geologist will look for. And when we see herringbone crossbedding, it's going to say, right, this is probably a tidal flat environment. We're also going to look for other features such as fossils, and we're going to say, right, these fossils are associated with salt water, and so that's once again going to give us a reasonable idea that this was a coastal tidal flat environment. And then finally, we have environments associated with the deeper marine settings. So these are environments associated with the continental slope and the deep seafloor. So the thing is, as I mentioned, just off the coast, there is something which is referred to as the continental shelf. And this is relatively shallow, between 0 and 200 meters deep. Now, when you come off the continental shelf, the ground, the seafloor, drops very, very quickly. Normally quite steeply, anywhere between about 90 and 70 degrees, so it's a very sharp drop. And this is referred to as the continental slope. So you come off the nice, gentle continental shelf, then you go flying down the continental slope. So any sediment that falls over the edge onto the continental slope is obviously going to flow downhill with quite a lot of energy. And so in continental slope environments, we tend to get these mass flows which occur underwater. And think of them like a landslide. And we call these turbidite flows. And once again, they're going to have very distinctive types of sediment and sedimentary structure that's going to allow us to identify them. And then finally, as we move into the deep marine environment, so the very deep ocean floor, this is going to be an environment where things are very, very still. The water is going to have practically no energy, and so we're going to have very, very fine muddy sediments being deposited. But not a lot of sediment actually makes it out that far, so the rate at which the sediment accumulates is going to be very, very slow. Compare that to somewhere like a delta, on the other hand, where you're having sediment constantly added. Well, the rate of sediment accumulation in the delta environment is going to be very, very high. So once again, you can see in these coastal and oceanic environments, we're going to have environments with distinct conditions, and this is going to lead to the formation of distinct sedimentary rocks. All right, thank you for watching, everybody, and have a good day.